Before sensors, screens, and software updates, bulldozers were built from pure iron and stubborn engineering. No warning lights, no computers, just massive steel frames, overbuilt drivetrains, and engines designed to run no matter how badly they were treated. Modern machines are smarter, but these were tougher. They worked where electronics fail. They kept going when everything else stopped. Many are still running today, decades later. This is the story of 10 classic dozers that laugh at modern machines. Old iron legends that prove durability never goes out of style. Number 1. Caterpillar D6B. The Caterpillar D6B is widely regarded by operators, mechanics, and fleet owners as one of the most reliable medium-sized bulldozers ever built. Produced mainly through the late 1960s and 1970s, the D6B came from an era when Caterpillar prioritized mechanical longevity, simplicity, and field serviceability over innovation for innovation's sake. This machine was not designed to impress on paper. It was designed to work every single day without excuses. At the heart of the D6B was the Cat 336 diesel engine, an engine that would go on to power countless Caterpillar machines across industries. This engine earned a reputation for exceptional durability, conservative power tuning, and tolerance for poor fuel quality, something modern engines with tight emissions controls simply cannot match. The D6B did not rely on electronics, sensors, or computerized engine management. Fuel delivery, timing, and power output were entirely mechanical, which meant problems were predictable, gradual, and usually repairable in the field. The transmission options on the D6B, primarily powershift configurations, were engineered to handle abuse. Operators could push heavy loads all day without worrying about overheating electronics or software derates. The undercarriage was another standout feature. For its size class, the D6B had a heavily built track frame and robust final drives, allowing it to operate in rocky terrain, forestry work, and road construction with relatively low wear rates when properly maintained. What truly sets the D6B apart from many modern machines is trust. Operators trusted it to start in cold weather, to keep running in dust and heat, and to keep working even when maintenance schedules slipped. Mechanics trusted it because diagnosing problems did not require laptops or proprietary software, only experience and basic tools. Even decades after production ended, D6Bs remain in active service across developing regions, small contractors, and private land operations. Parts availability remains strong due to the massive production numbers and the shared legacy of the 3306 engine. The D6B does not beat modern dozers through technology, it does so through predictability, toughness, and mechanical honesty, qualities that never go out of style. Number 2. Allis-Chalmers HD21. The Allis-Chalmers HD21 represents a philosophy of earth-moving that modern manufacturers have largely abandoned. When in doubt, add weight and strength. Introduced in the late 1950s, the HD21 was one of the largest crawler tractors of its era and was specifically designed for mining, dam construction, and heavy overburden removal, jobs where smaller machines simply could not survive. Weighing well over 50 tons depending on configuration, the HD21 relied on mass to generate traction. This allowed it to push enormous blade loads and support scraper fleets long before ultra-high horsepower dozers became common. Rather than chasing speed, Allis-Chalmers designed the HD21 to work slowly, steadily, and relentlessly. Its powertrain emphasized torque at low engine speeds, reducing stress on internal components and extending service life. Structurally, the HD21 was massively overbuilt. Frames were thick, final drives were oversized, and blade mounting points were designed to absorb shock without cracking. This was not accidental. During the HD21's production era, downtime in mining operations was extraordinarily expensive, and replacement machines were not always readily available. As a result, Allis-Chalmers engineers prioritized survivability over efficiency. Another defining characteristic of the HD21 was its mechanical transparency. Failures were almost always mechanical and visible. Leaks, noise, vibration, rather than sudden electronic shutdowns. Skilled operators could feel problems developing and adjust their operation accordingly. Mechanics could rebuild major components without factory intervention, making the HD21 ideal for remote job sites. Many HD21s remained in service for decades. often passing through multiple owners and industries. Some were eventually retired, not because they failed, but because their sheer size and fuel consumption no longer matched evolving job requirements. Even so, the HD21 earned a reputation as a machine that could be abused, overloaded, and still come back for more. In a modern context, the HD21 laughs at newer machines because it embodies a lost design ethic. Build it once, build it heavy, and let it work until it physically cannot anymore. Number 3. International Harvester TD25. The International Harvester TD25 was built during a time when earth-moving success depended more on torque, cooling capacity, and mechanical durability than on efficiency metrics or electronic control systems. Introduced in the 1960s, the TD25 quickly gained recognition as one of the most powerful and capable dozers in its class, especially in land clearing, mining support, and oil field operations. International Harvester designed the TD25 with a clear purpose: sustained heavy pushing in harsh environments. The machine's large displacement diesel engine was tuned for low RPM torque rather than peak horsepower, allowing it to maintain traction and momentum in difficult ground conditions. This made it particularly effective when ripping hardpan, shale, or compacted soil where smaller machines would stall or lose grip. Cooling was a major focus in the TD25's design. Oversized radiators and straightforward airflow paths allowed the machine to operate for long hours in hot climates without overheating, an advantage that made it popular in Australia, North America, and parts of the Middle East. Unlike modern engines constrained by emission systems, the TD25 could run hot, dusty, and overloaded without triggering protective shutdowns. Mechanically, the TD25 was simple but strong. Its drivetrain components were built with generous safety margins, and maintenance access was straightforward. Field repairs were common and expected, and the machine's design supported that reality. Operators valued the TD25 because it delivered consistent performance regardless of conditions. While the TD25 lacked the refinement of later machines, it made up for it with raw authority. When the blade dropped, the machine pushed. No hesitation, no electronic intervention. That sense of direct mechanical connection is something many experienced operators still miss today. Number 4. Komatsu D355A. The Komatsu D355A is one of the most important bulldozers ever built. Not because it was the largest, but because it marked the moment when Japanese heavy equipment proved it could outperform established Western competitors in large-scale mining operations. Introduced in the 1970s, the D355A quickly gained acceptance in mines where uptime, fuel efficiency, and component life mattered more than brand loyalty. Komatsu approached the D355A with a different philosophy. Rather than maximizing horsepower, engineers focused on balanced performance, adequate power, excellent cooling, long-life undercarriage components, and conservative engine tuning. This resulted in a dozer that could run longer between major overhauls while consuming less fuel than many rivals in its class. The D355A's frame and blade design were optimized for continuous production work, particularly push-loading scrapers and maintaining haul roads. Operators appreciated the machine's stability and predictable handling, which reduced fatigue during long shifts. Mechanics appreciated the consistency of Komatsu's component design, which made preventive maintenance easier and more effective. One of the D355A's greatest strengths was its reliability in remote locations. Mines with limited dealer access favored it because it did not require constant specialized support. Parts wore slowly, failures were gradual, and rebuilds were economical compared to some competitors. The success of the D355A forced the global industry to rethink assumptions about equipment quality and durability. It demonstrated that precision manufacturing and conservative engineering could rival brute force, reshaping expectations for future dozer design. Number 5. Euclid TC-12. The Euclid TC-12 is one of the most overlooked heavy bulldozers in history, largely because the company became famous for haul trucks rather than crawler tractors. Yet during the 1950s and early 1960s, Euclid was deeply involved in surface mining solutions, and the TC-12 was designed as a purpose-built mining support dozer, not a general construction machine. The TC-12 was engineered to work alongside Euclid's massive off-highway trucks in open-pit mines. Its role was not finesse grading or light clearing. It was haul road maintenance, overburden movement, and scraper support under constant load. As a result, Euclid focused on durability, cooling capacity, and traction, rather than speed or operator comfort. One of the defining characteristics of the TC-12 was its sheer mass. Weight was intentionally used as a productivity tool. In mining environments, traction matters more than horsepower, and the TC-12 could maintain steady push force in loose overburden where lighter machines struggled. The drivetrain was conservative and slow revving, reducing heat buildup and extending component life during long shifts. Euclid also designed the TC-12 with mining maintenance realities in mind. Mines often ran their own workshops far from dealer networks. The TC-12's mechanical systems were straightforward and rebuild-friendly, allowing engines, finals, and hydraulic components to be serviced repeatedly rather than replaced. This philosophy extended the machine's usable life far beyond what would be acceptable in modern fleet economics. Many TC-12s worked for decades before being scrapped, and most were retired due to changes in mine scale rather than mechanical failure. When larger, more efficient machines became available, the TC-12 was simply outgrown. In today's context, the TC-12 laughs at modern machines because it represents a time when mining equipment was built to survive abuse first and optimize efficiency second. It was never fragile, never sensitive, and never designed to quit when conditions turned ugly. Number 6. Fiat-Allis FD30. The Fiat-Allis FD30 emerged during the 1970s, a period when the heavy equipment industry was undergoing consolidation and globalization. This dozer represents a rare and successful blend of European manufacturing discipline and American heavy-duty expectations. Unlike many transitional machines of that era, the FD30 earned respect on tough job sites. The FD30 was not the largest dozer in its class, but it was exceptionally well balanced. Fiat-Allis engineers focused on chassis rigidity, final drive strength, and efficient power transfer. The result was a machine that could punch above its weight, especially in rocky terrain and cut-and-fill operations. One reason the FD30 gained a loyal following was its structural integrity. Frames resisted twisting, blade mounts held alignment, and undercarriage wear was predictable rather than catastrophic. These traits made the machine popular in quarrying, pipeline work, and infrastructure projects where ground conditions changed constantly. Mechanically, the FD30 avoided unnecessary complexity. Its engine and hydraulic systems were robust and accessible, allowing maintenance without specialized equipment. Operators appreciated the machine's responsiveness and control, particularly when precision mattered as much as pushing power. The FD30 also aged well. Many machines retained tight controls and consistent performance even after years of use, reflecting conservative tolerances and high-quality machining. That long-term stability is something modern machines sometimes struggle to maintain due to weight reduction and component optimization. In short, the FD30 earned its reputation not through size or marketing, but through quiet reliability and balanced design. It is a classic example of how thoughtful engineering can produce a machine that remains relevant long after its production ends. Number 7. Case 1150C. The Case 1150C does not appear in many legend lists, but among contractors who actually ran them, it earned deep respect. Introduced in the 1970s, the 1150C was designed as a practical, affordable, and durable mid-size dozer for real-world construction work. Case focused on mechanical simplicity. The naturally aspirated diesel engine was dependable and forgiving, capable of starting after long storage and running under inconsistent maintenance. The drivetrain was built to tolerate operator error and heavy loads, making it suitable for mixed crews and municipal work. One of the 1150C's strengths was versatility. It worked equally well in road construction, landfill operations, site prep, and agricultural land clearing. The undercarriage was durable for its class, and blade control was predictable, making it easier for less experienced operators to be productive. Maintenance access was another advantage. Components were easy to reach, and common wear items could be replaced without disassembling half the machine. This made the 1150C especially attractive to small contractors who relied on in-house repairs. Many surviving 1150Cs today are still operational, often having outlived newer replacements. Their longevity stems from mechanical tolerance and conservative design, not advanced features. The 1150C proves that a machine doesn't need to be extreme to be legendary. It just needs to work, day after day without drama. Number 8. John Deere 850. The John Deere 850 marked a crucial moment for Deere, signaling its serious entry into the heavy bulldozer market. Introduced in the late 1970s, the 850 was built to compete directly with established leaders, and it succeeded by emphasizing operator control, balance, and durability. Unlike earlier Deere crawlers, the 850 was purpose-built for heavy construction. It featured a strong undercarriage, responsive hydraulics, and a well-balanced chassis that reduced operator fatigue during long shifts. While it wasn't the heaviest or most powerful dozer in its class, it was efficient and predictable. Operators often praised the 8550 for its smooth blade response. Fine grading, slope work, and controlled pushing were areas where it excelled. That precision did not come at the cost of toughness. The machine could still handle hard pushing when required. The 850's engine and drivetrain were tuned conservatively, prioritizing reliability over peak output. This allowed the machine to accumulate high hours with fewer major failures. Many units remained in service on farms, quarries, and construction sites long after newer models arrived. The John Deere 850 earned its place as a classic because it proved Deere could build a serious, durable dozer without copying competitors outright. It combined Deere's agricultural durability mindset with true earth-moving capability. Number 9. Liebherr PR 751. The Liebherr PR 751 represents a very different bulldozer philosophy from most American machines of its era. Developed in Europe for quarrying, alpine construction, and long-term industrial work, the PR 751 was designed around one core principle: structural longevity under continuous load. Instead of chasing headline horsepower or oversized blades, Liebherr focused on frame rigidity, undercarriage life, and controlled power delivery. From the beginning, the PR 751 was intended to work in environments where machines were expected to last decades, not leasing cycles. European quarry operators demanded predictable wear rates, not maximum short-term output. As a result, the PR 751 featured a heavily reinforced chassis that resisted torsional flex, which is a major contributor to frame cracking and component misalignment over time. One of the defining strengths of the PR 751 was its undercarriage engineering. Liebherr paid close attention to track geometry, roller alignment, and load distribution, resulting in slower, more uniform wear. While some competing machines delivered higher initial push force, they often consumed undercarriage components at a faster rate. The PR 751, by contrast, maintained consistent performance over long service intervals. Hydraulic systems on the PR 751 were designed for precision rather than aggression. Blade movements were smooth and controlled, reducing shock loads on pins, cylinders, and mounts. This not only improved grading accuracy but also extended component life. Operators often noted that the machine felt tight, even after many thousands of hours, a hallmark of conservative engineering. Another reason the PR 751 earned classic status is its aging behavior. As the machine accumulated hours, performance degraded slowly and predictably. There were no sudden electronic failures or cascading system shutdowns. Maintenance planning was straightforward, and rebuilds were economically viable well into the machine's later life. In a modern context, the PR 751 laughs at newer machines because it was never optimized for short-term efficiency metrics. It was optimized for decades of controlled, dependable work, something that still matters deeply in quarrying and infrastructure projects where downtime is far more expensive than fuel consumption. Number 10. Hanomag K12. The Hanomag K12 stands as one of the purest examples of early bulldozer design, created in an era when heavy equipment engineering was driven by necessity rather than competition. Built primarily in the mid-20th century, the K12 emerged in post-war Europe, where machines were expected to rebuild nations under extreme material shortages and brutal working conditions. The K12 was entirely mechanical. No hydraulic complexity by modern standards, no electronics, and no attempt at operator comfort beyond basic ergonomics. What it offered instead was absolute mechanical honesty. Every movement, every vibration, every load transfer could be felt by the operator, allowing skilled hands to extract maximum performance without overstressing the machine. Structurally, the K12 was massively built for its power class. Steel quality and thickness reflected a time when over-engineering was considered good practice, not inefficiency. Frames resisted cracking, and components were designed to be repaired repeatedly rather than replaced. Welding, machining, and improvisation were expected parts of ownership. The K12 earned its reputation during Europe's Reconstruction period, where it worked continuously on roads, railways, industrial sites, and agricultural land conversion. Spare parts were often scarce, yet the K12 kept running because it could accept substitutions, repairs, and adaptations without catastrophic consequences. From a modern perspective, the K12 appears primitive, but that simplicity is exactly why it deserves classic status. Modern machines often shut down to protect themselves. The K12 relied on the judgment of the operator and the strength of its materials. When things broke, they broke visibly and slowly, giving crews time to respond. The Hanomag K12 laughs at modern machines because it represents a lost era of equipment design, one where survivability mattered more than optimization and where a machine's value was measured in decades, not resale curves. So that's it for today. If you liked this video, then please hit the like and subscribe button for more videos. Thanks for watching.